Good morning, students. Students, in our previous lecture, we started with the discussion of volumetric calculations. And we discussed in that what is molarity. I recapitulate that molarity is defined as the number of moles of solute present per liter of the solution. Molarity was represented by the symbol small m. Then we did certain formulas such as molarity of dilution. M1V1 was equal to M2V2. Molarity of mixing, M1V1 plus M2V2 and so on will be equal to MrV1 plus V2, where Mr was called as the resultant molarity. Then I told you, if in a numerical problem it is given X% of a solute is dissolved in the solution having a density d gram per ml, then the molarity was equal to X% into d into 10 upon molecular mass of the solute. Now, the next way of expression of the concentration of the solution is molality of the solution. So, first was molarity, next is molality of the solution. Molality. Molality of the solution is represented by small m. What is molality? It is defined as number of moles of solute present in a kg of a solvent or dissolved in a kg of a solvent. So, it may be given as the ratio of number of moles of solute, then volume of a solvent taken in a kg. So, number of moles of solute, molality will be equal to number of moles of solute, number of moles of solute upon mass of solvent in a kilogram. Number of moles of solute upon mass of solvent in kilogram. Am I clear? So, molality is equal to the number of moles of solute upon the mass of a solvent in kilogram. Number of moles of solute. So, molality, let me write it with a small m representation. Number of moles of solute given mass upon molecular mass. Now, you may get confused between this small m and small m. So, let me write it as Wa upon Ma. It is the given mass of a solute is Wa. Ma is the molecular mass of a solute. M stands for the molality of the solution into mass of a solvent in kg. So, into given mass of a solvent. Let it be represented by W, capital W, and this will be in kilogram. I think I shall be clear. So, how we define molality? It is defined as the ratio of number of moles of solute upon mass of a solvent in kg. Now, if the mass is taken in grams, then formula can be, or we may say, it can be represented as M will be equal to Wa upon Ma into W multiplied by 1000. Multiplied by 1000 over here. So, if the mass of a solvent is in grams, so formula will be equal to Wa upon Ma into W into 1000. What was the molarity formula that we discussed that day? I told you that molarity was equal to W upon M, molarity, W upon M into V into 1000. Remember the formula? So, first way of expression of concentration of the solution was molarity. That was discussed in the last lecture. And the another way that we have discussed today is molality. Molarity is represented by capital M. Molality is represented by small m. It is the ratio of number of moles of solute upon volume of the solution in liters. Here it is the ratio of number of moles of solute upon mass of a solvent in kilogram. How do we represent molality? Small m. Molarity, capital M. So, molality, if mass of a solvent is given in grams, it will be Wa upon Ma into W multiplied by 1000. I think I shall be very clear. So, two way of expression of a concentration of a solution we have done. One is molality, other one is molarity. Now, if in any solution density is given and from molality we have to find out the molality, from molarity we have to find out the molarity of the solution. So, relationship between molality and molarity, a direct relationship I am telling you, which will help you to solve the numerical problem in a single step. Otherwise, you will be using almost more than half of the page to solve the numerical problem. Here we will be solving by the single step. So, relationship between molality and the molarity over here. Relationship between molality, relationship between molality and molarity, between molality and molarity of the solution. A formula which will help you to solve the numerical problem in a single step. Always remember, 1 upon molality of the solution. This will be equal to 1 upon molarity of the solution minus, this will be equal to density of the solution upon molarity of the solution. This will be density of solution upon molarity of the solution. Density of the solution upon molarity of solution minus molecular mass of solute upon 1000. Am I clear? Minus molecular mass of solute upon 1000 minus molecular mass of the solute upon 1000. Is it clear? So, how do we find out the molality of the solution? 1 upon molality of the solution will be equal to the density of the solution upon molarity of the solution minus molecular mass of the solute upon 1000. Or we can say 1 upon molality, small m. This will be equal to density of the solution upon molarity of the solution minus molecular mass of solute, let it be Mb, or molecular mass of solute upon 1000. This is molarity. If I say Ma, this will be molecular mass of solute. Am I clear over here? Molecular mass of solute. This will help you to solve the numerical problem. Especially when we go for the entrance examination, where we have to solve the multiple choice question. These kind of relationships help a lot in solving the numerical problem. One student can solve the same problem in few seconds. Other students may take few minutes to solve the problem. That is a difference that can only be done if you know the final tricks of solving the numerical problem. If molality, molarity and density of the solution is given, whatever way you make the calculation, the last step of the calculation is supposed to be this one, which can be obtained as a direct formula to find out the molality or molarity. Suppose in the question, molality is to be found out. So the density of the solution must be known to us, molarity must be known to us, and then molecular mass of a solute must be known to us to find out the molality of the solution. Am I clear? So two ways of volumetry, two ways to carry out the volumetric calculations has been discussed. First is the molality of the solution and second was the molality. Spell it out, M-O-L-A-L-I-T-Y. This was M-O-L-A-R-I-T-Y. Molarity is represented by capital M. Molality is represented by small m. Am I clear? So, the two ways of expression of a concentration of a solution we have done. Now, if I say the third way is the strength of the solution, is the strength of a solution. How do we express the strength of a solution? The strength of the solution will be equal to W upon V. This is W upon V. This is in gram per liter. So we define it as the mass of a solute present in the V liter of the solution. So this is a mass of solute. Mass of a solute. And what is V over here? V is the volume of the solution in liter. Mass of solute to the volume of solution in liter. Am I clear? So how do we define the strength of the solution? It is a ratio between the mass of a solute dissolved in V liter of the solution. Three ways are clear. Now the fourth very important way of calculating in the volumetric calculation is normality of the solution. Fourth way. This was the third way. Now the fourth way is normality of solution. Very, very important topic. Normality. How do we account for normality of the solution? Remember the equivalent weight we have discussed with you? Normality of the solution is given by the symbol capital N. How do we define it? It is defined as number of gram equivalent of the solute present in V liter of the solution. So how do we define normality? It is defined as number of gram equivalent of solute, defined as the number of gram equivalent of solute dissolved in means present in V liter of the solution. Dissolved in V liter of solution. So number of gram equivalent of the solute dissolved in V liter of the solution is called as a normality of the solution. How do we express normality? By capital N. So as a formula it can be written as a ratio of number of gram equivalent of the solute upon the volume of the solution in liter. So normality of the solution will be equal to number of gram equivalent of solute upon volume of solution in liters. Am I clear? Upon volume of solution in liters. Suppose number of gram equivalent. This will be W upon E. What is the E over here? Equivalent mass. Multiplied by the volume of the solution in liters. This will be what? This will be the normality of the solution. So normality of the solution will be equal to W upon E into V. If volume of the solution is given in ml, if volume of solution is in milliliter, then what will be the formula? Normality will be equal to W upon E into V multiplied by 1000. Am I clear? Formula will be equal to W upon E into V into 1000. What is E over here? E is the equivalent mass of the solute. Do you remember the formulas to calculate the equivalent weight? We did this in the previous lecture. Equivalent weight of acid will be equal to molecular mass divided by basicity. Equivalent mass of base will be equal to molecular mass divided by acidity. Then equivalent mass was equal to the molecular mass divided by the number of electrons lost or gained in an oxidizing agent or as well as in the reducing agent. So various ways of calculating the equivalent mass we did. Suppose in any question it is given, calculate the normality of 49 gram of sulfuric acid dissolved in 1 liter of a solution. Suppose the question is calculate normality of 49 gram of a sulfuric acid present in 1 liter of the solution. So what formula we will use? N will be equal to W upon E into V into 1000. What mass of sulfuric acid? 49. What is the equivalent mass of sulfuric acid? Equivalent mass, I told you earlier also, equivalent mass of H2SO4. This will be equal to the molecular mass of H2SO4 will be what? 98. How many? What is the basicity over here? 2. So divided by 2, it will be equal to 49. So 49, what is the volume given? 1 liter. Fine. If the volume is in liters, then it will be this formula. So answer will be what? 1 normal. Am I clear? This is how we solve the various numerical problem of a normality of a solution. So by now, how many ways of normality we have done? Of a volumetric calculation we have done. First was the molarity of the solution. Second was the molality of the solution. Then the volume strength, or I must say strength in gram per liter, not the volume strength, strength of the solution. And fourth was the normality of the solution. Now, after normality of the solution, the next is the various ways by which the normality can be calculated. First is normality of dilution. Normality of dilution. The formula will be N1V1. This is the formula we normally use in the lab to prepare the solution of unknown solution of a desired strength or any strength. N1V1 will be equal to N2 into V2. So normality of dilution is N1V1 will be equal to N2V2. This is before dilution. This is before dilution. And then after dilution. Before dilution and after dilution. Am I clear? Suppose we have to prepare a normal solution of any acid. So we must know the standard normality of that acid, what strength we require, what volume we require, and what volume of this will be used. Then normality of mixing. Normality of mixing. The formula to calculate the normality of mixing will be N1 V1 plus N2 V2, and this will be equal to NR into V1 plus V2. NR is our resultant normality. Resultant normality of the solution. Am I getting clear? N1 V1 plus N2 V2 will be equal to NR into V1 plus V2. What do I mean by this? Suppose we have a sample A. First, or a sample A and a sample B of two solutions. Suppose the normality of this is a 1 normal. Volume of this is a 1 liter. Normality of this is 2 normal. Volume of this is 2 liter. Now suppose these two solutions are mixed. My question is, what will be the resultant normality? The two solutions over here. Suppose it is an acid solution of HCl. It is again the acid solution of a same basicity. These two solutions are mixed. My question is, what will be the resultant molarity? So formula will be used. It will be 1 into 1 plus 2 into 2. This will be equal to NR. We have to calculate volume of the solution will be equal to 1 plus 2. So from here, we will find out the resultant normality of the solution. Am I clear? So, if two samples of the same acid or base are given with a different normality and different volumes, then their resultant normality can be calculated if the two solutions are mixed. Here we find out the normality of dilution. Now, one more thing must be taken care of, and learn it as a formula. If X% of solute is dissolved in the solution or is present in solution having density d gram per ml, then normality will be equal to X% into D into 10 upon equivalent mass of solute. Upon equivalent mass of solute. Am I clear? If in any question percentage mass of solute is given, density of the solution is given, we can calculate the equivalent mass. Then numerical can be solved by the application of a direct formula. Normality of the solution will be equal to X% into D into 10 upon equivalent mass of a solute. I think I shall be very, very clear. Am I? Now, relationship. Between normality and molarity of the solution. Between molarity and normality of the solution and normality of solution. Relationship between the molarity and the normality of the solution. Just see over here. What is molarity? This will be equal to W upon M into V. What is normality of the solution? This will be equal to W upon E into V. What is this W upon V? Strength of the solution. So molarity into molecular mass will be equal to the strength of the solution. Similarly, normality into equivalent mass. Normality into equivalent mass will be equal to the strength of solution. Am I clear? Now comparing these two equations. If you compare these two equations, comparing, suppose this is equation number 1 and this is equation number 2. So what do we get? Molarity into molecular mass This will be equal to normality into equivalent mass. So by this relationship, if suppose molarity of the solution is given, normality can be obtained. Am I clear? So one more relationship we have obtained, that is the relationship between the molarity and the normality of the solution. Yes or no? This molarity divided by normality will be equal to equivalent mass divided by the molecular mass, which can also be equal to the n factor. Now the next way of expression of a concentration is mole fraction. Next way of expression of concentration is mole fraction. First was molarity, second was molality, third was the strength of the solution, fourth was the normality of the solution, fifth one is mole fraction. Mole fraction of any solute or solution is given by the symbol X. It is defined as the number of moles of solute divided by the total number of moles in the solution. So how do we define it? It is defined as number of moles of solute divided by total number of moles in solution. Total number of moles in solution. Suppose we have a substance A and a substance B. Let me say the number of moles of a substance A is Na and number of moles of substance B will be Nb. If I find out the mole fraction of this, mole fraction of A will be equal to number of moles of A plus number of moles of A plus number of moles of B. Am I clear? Number of moles of a particular component divided by the total number of moles of a solution. In fact, the right word would have been number of moles of a particular component divided by the total number of moles in solution. Number of moles of particular component divided by the total number of moles in solution. Is it clear? Mole fraction of component B will be equal to number of moles of component B divided by the total number of moles of component A and B. If I sum up this, XA plus XB, this will be equal to 1. Just see this, Na upon Na plus Nb plus Nb plus Na upon Nb. If you sum up this, will be equal to 1. So always remember, sum of mole fraction is always unity. Sum of mole fraction is always unity. Am I clear? XA plus XB will be equal to 1, or I must say sum of the mole fraction will always and always be equal to unity. Molarity and normality changes with the change in temperature, but mole fraction does not change with the change in temperature, because mole fraction is independent of volume. So molarity and normality changes with temperature, but mole fraction does not change with change in temperature. Does not change with change in temperature. With change in temperature. Mole fraction does not change with the change in temperature. Is it clear? Now one more formula, and that will be the relationship between molarity and mole fraction. So relationship between molarity and mole fraction. Relationship between molarity and mole fraction. Between molarity and mole fraction. What will be the relationship between the molarity of the solution and the mole fraction of the solution? Very, very important formula to calculate the numerical problem. Always remember, molality of the solution will be equal to mole fraction of the solute. This will be equal to molality of the solution will be equal to mole fraction of the solute. Mole fraction of solute upon mole fraction of solvent upon mole fraction of solvent into molecular mass of solvent multiplied by 1000. Very, very important formula to solve the numerical problem. Or we may write down this formula is this way: molality will be equal to mole fraction of solute. Let me represent it by XB. XA plus XB will equal to 1. So this will be equal to 1 minus XB into molar mass of solvent multiplied by Ma into 1000. This will be the formula to calculate the molality of the solution if the mole fraction is given. I think the things must be very, very clear to you. So what is mole fraction? It is defined as the ratio of number of moles of number of moles of a particular component divided by the total number of moles in a solution. Suppose we have a solution of a component A and B. The number of moles of component A is Na, number of moles of component B is Nb. So what will be the mole fraction of this? Number of moles of this component divided by the total number of moles in the solution. Number of moles we all know is given by the formula given mass upon molecular mass. So this can also be used. Similarly, the mole fraction of the component B will be equal to number of moles of the component B divided by the number of moles of component A and the number of moles of a component B. Sum of mole fraction is always and always equal to unity. So XA plus XB will be equal to 1. Molality and normality changes with the change in temperature, but mole fraction does not change with the change in temperature. Am I clear? What is the relationship between molality and mole fraction? Molality will be equal to XB upon 1 minus XB into 1000 upon molecular mass of a solvent. These were certain ways by which the concentration of a solution can be expressed. So what various ways we have done? Molarity, then molality, then normality, then the strength of the solution and the mole fraction. Hopefully you must have understood all these. I hope you are understanding what I am wanting to teach. In a solution, how can the concentration be expressed? Go through these video lectures very, very thoroughly. Watch them again and again to understand the concept. I have suggested you to make the notes In the next lecture, we'll be proceeding ahead by solving certain numerical problems. Doubt session will be conducted. For any problem, you can take your doubts. The classwork of the same will be given. And hopefully, you will do all your work. Hoping that you will be revising your work very, very thoroughly. We'll be soon coming to you with the next lecture.